In this video I want to graph a number of different sine curves. Let's go ahead and review the graph of plain old sine of x. So when I graph the sine, I'm going to use two key pieces of information that we've learned in a previous video. The sine of x has a period of 2 pi and an amplitude equal to 1. So a period is how long it takes for a complete cycle. So to graph the first cycle, I'm going to go out a full period of 2 pi and then chop it into quarters. So pi over 2, pi, 3 pi over 2. Okay. My amplitude is 1. So I'm going to throw in a couple of guides at y equal to 1. And the other horizontal line here, y equal to negative 1. Okay. So the sine of x, when you put in 0, you get 0. Pi over 2, you get 1. Pi down to 0. 3 pi over 2, negative 1, and back up to 0. Okay. And let's do the same thing on the left. So again, my quarters are pi's over 2. So negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, down to negative 1, 0, up, back down. Okay. So here's a graph of the sine of x. Of course, it continues to repeat in both directions. Importantly, and this is something that we learn from the unit circle as well, but notice that regular old sine of x is always, its absolute value is always less than or equal to 1. Or in other words, the sine of x is bound between negative 1 and 1. Okay. Let's look at a couple other graphs. Instead of the sine of x, let's graph 2 times the sine of x. Okay. If you recall from algebra, what this multiplying our function by 2 is going to stretch it vertically. Okay. So now, period is still 2 pi. I haven't changed my x values, or I haven't changed x in any way. So the period is still 2 pi. But now my amplitude is going to equal 2, right? Because I stretched my graph vertically by a factor of 2. So to graph this, my horizontal lines, I'm now going to throw in 2 and negative 2. Okay. Period is 2 pi. So I'm going to go out a full period and then again chop this period into quarters. Pi over 2, pi, 3 pi over 2. Okay. So now, when we put in 0 for x, we still get 0, but at pi over 2, I jump up all the way to 2, then back down to 0, down to negative 2, back up to 0. And the left side also. Okay. So there's the graph of 2 sine x. All I did in my mind was just take the graph of sine of x and stretch it vertically. Let's do one more. What if we were to graph -3 sine of x? Okay. The 3, again, stretches the graph, this time by a factor of 3. Right? The negative is just going to flip our graph. So my amplitude is going to be 3. The only difference here between this one and the last one is I have to take into account the negative out front. So I want to go up to y equal to 3, down to y equal to -3, go out my period of 2 pi, chop it into quarters, but now with my negative, right, instead of going up to pi over 2, right, remember it flips the graph about the x-axis, I'm going to go down to -2. Then up to pi, up to 3 pi over 2, I'm sorry, up to 0 at pi, up to 3, and then back down to 0. And let's put down the left side as well. And so from here, we're going to go up, back down to 0, down to -3, back up to 0. Okay. So there's the graph of -3 sine of x. In general, we have the following statement. Given f of x equal to some number times the sine of x, the amplitude is going to be the absolute value of a. Here, our a was a -3, so the amplitude was 3.